Hello, welcome to a project Petrol Price Forecasting. The main aim of this project is to predict or to forecast the correct oil prices for the upcoming dates using the different machine learning techniques and then eventually the automated machine learning techniques. Now, what is the motivation behind this project? In a report, it was suggested that in the long term, the Indian gasoline prices is projected to trend around 1.05 US dollars per liter in 2022 and 1 US dollar per liter in 2023, according to the econometric models. So, what do you understand about this statement? This statement, how did they came to the analysis that this will be the results? This all was done with the help of different econometric models, which are basically the deep learning models, which will be seeing the demonstration in this project. As we know, petrol prices are going up continuously up these days, and it has become very hard to predict what will be the price range in the next few months or even a few days. Right now, in our situation, the in our country, the situation is the petrol price keep changing from months and from days to days. Now, what we can do about it? We can create a machine learning model, the like the one which I told you about these econometric models. Similarly, we can also create a model in this project. We will try to forecast the different petrol prices for the upcoming dates given to us. We'll be using different forecasting models like LSTM and ARIMA. I'll be explaining you further. But these models to predict the prices, and then we'll see how we can implement the same using Keras, which is an auto machine learning library. Now I have talked about the automated machine learning, so let's talk about it a bit. AutoML enables developers with limited machine learning expertise to train high quality models specific to their business needs. Now, when you see in the project, you'll see that there is a high requirement of data science knowledge and basic concepts to implement these models. But with the help of automated machine learning, you can implement these models without that hustle, and it will do all the work for you, and it performs pretty good actually. Now, let us discuss about the forecasting models we will use in the deep learning methods. Forecasting basically means is to predict. Forecasting a news report, forecasting a weather report, forecasting a weather report, forecasting stock price prediction or any of that sort. So we'll be using two models. One is the LSTM. LSTM is the long short-term memory. A long short-term memory model is a artificial recurrent neural network architecture used in the field of deep learning. LSTM has feedback connections. It can process not only single data points but also entire sequence of data, which we will be doing in this project. And the second one model is the ARIMA model. It is quite average, and it was first. This was the first model developed in the deep learning process. It is a model or is a class of statistical models for analyzing and forecasting time series data. Time series data basically means which keeps changing with time, like this petrol prices or the stock prices, you can say. ARIMA is a acronym that stands for Auto-Regressive Integrated Moving Average. It is a generalization of the simple auto-regressive moving average and adds the notion of integration. Now, it is often said that LSTM performs well in a time series data than ARIMA, or it depends on the data set. We'll see how these models perform in our project. Now, talking about the automated machine learning, we'll be using the AutoKeras library. AutoKeras library uses all the TensorFlow libraries, and it is an AutoML system based on Keras. You are all familiar with the Keras module. It is developed by the Data Lab at Texas A&M University. The goal of AutoKeras is to make machine learning accessible to everyone. There are various applications of AutoKeras. This basically the same concepts which you can do with the help of deep learning. These are the regression problem, image classifier, object detection. We here the forecasting technique is the image regressor. Forecasting technique is a regression problem. Now, what will be the timeline of the project? First is the data analysis, but basically we have a single data which we'll find out in the next section. We don't have much to do in the data analysis part. Will be performing a very important steps in the data pre-processing. I'll be explaining you those that how we have to pre-process the data in order to feed that data into a deep learning models like the LSTM and ARIMA. Then we'll build the model using the MLDL techniques, and then we'll eventually begin to build our model using the AutoKeras, that is a auto machine learning technique. So in the end of this project, by the end of this project, you will be able to implement all of these on your own in the same project, or you can develop something on your own. So let's begin. Hello. So now let's begin with a project, petrol price forecasting using TensorFlow and AutoKeras. So as you know, I've already discussed about how and what is the need of this project and what was the motivation around this. The same is written here. We'll be using LSTM and ARIMA forecasting models to predict the prices. Then we'll see how we can implement the same using AutoKeras, which is an auto machine learning library. Now, the timeline of the project. The data analysis part and the pre-processing part is also included in this. Then the model building and predictions using machine learning techniques. Then model building and prediction using AutoKeras techniques. Now, first we have to import our libraries and our data. So we'll be importing our libraries, which is the pandas, numpy, matplotlib for visualization. And as this is a Google Colab environment, so there's a certain procedure to import the data. All you have to do is the file which you want to import. You just upload it on your drive. Then you do write this command. You can simply write this command by going this and clicking on this option, mount drive. Then this command will appear. You just execute it. Now it will provide you a URL. Go to this URL. It will tell you to select an account. You just give the access to this account and copy the link. After copying the link, paste it here, press enter. It will run for few seconds. So see, this is the authorization code. Now mounted at content drive. Now as I see that my drive is mounted. What I'll do, I'll go here and I'll see a option drive. And this is the my drive. This is the data which is present in my drive. Okay. Now what I have to do, I have to select the file, CSV file which I want to import in this. I'll go down and I'll see this is my file data. I'll just copy the path train data.csv. I'll paste the path here and I'll just execute the command. Okay, so this is how I imported my libraries and the data. This was a simple step in which I demonstrated how you can import your data. Only thing you have to do is you just have to upload your files, as this is a Google Colab environment and this does not works on your local machine. It provides the RAM and GPU of the different Google servers. So as you can see here. And if you are doing it in your local environment like the Jupyter notebook, you can directly access the data from there. But in the Google Colab environment, you have to follow these steps and import your data into a Google Drive in order to upload your or to do work in your Google Colab. This was the importing libraries introduction part. In the next section, we'll see the data analysis and the data pre-processing part, how we will pre-process the data and what are the things required for it. Hello, welcome to our next section of the project. In this section, we'll be doing the data analysis and splitting the data into a train and test part. So now let's first have a look at the data, the original data. What we'll do, df1 dot head. Now, as you can see, this is the DF1, right? This is the data. As you can see, there is not much in the data. What happens in the time series of forecasting problem, we simply use a one column in which we'll see that the model will see the different trends and then predict us what will be the next values will be. Now let's see if this have some of any null values or not. DF the there are two null values. We'll simply drop the null values. Then what we'll do, we'll rename the petrol USD to petrol just for simplification. Now this is our date and this is our petrol. Now we'll try to plot a scatter plot to see how our petrol prices are distributed. Now, as you can see, this is a scatter plot. This is the which shows that how our plot is, how our prices are distributed. These are some of the outliers in the 180 part. We can drop these for sure because these are of no importance or will not make much difference. What we'll do, we'll make a new data set DF3 in which we'll say if the petrol prices are less than 160, give me those values, which is 160 is basically the cap, more than the cap. So I'll make a one new data set which is df3, and then make a scatter plot which will be more prominent looking. Now, as you can see, this is our data in which how our data is distributed, and the maximum cap is 140. So the graph is still there only. Now what I'll do, I'll reset the index. I'll reset the index to convert this data into a more convenient form, or to give my data into a min-max scaler. Now what happens is LSTM models are very sensitive to the scale of the data. So we should always try to transform this value. In this case, we'll be using the min-max scaler. So we'll be importing it in from the sklearn.preprocessing, import min-max scaler. In the min-max scaler, first I'll use the range 0 to 1. This is the value you have to give if you want to scale down the value to 0 to 1. Okay. Now, as you can see, our value is scaled, and this is the command scalar.fit transform np.array reshape. This you have to do in order to give your data so that it can process the data and the under the fit transform. So if you want to see your df4 how it looks, as you can see, it has converted into an array. This data has been converted into an array in which the values are scaled down. Now, if we look at our data, it has got transformed between 0 to 1. Earlier, it was like this, around 74. It was a numeric value, right? Now, it has transformed all the data into 0 to 1 and has given us in the form of array. Now, going down, now the most important thing is the pre-processing technique. For that, we have to do train test split. Okay. Now, in this, the train test split is done in a different way, because what happens is, suppose you have a data of around 120, 130, 140, 150, and so on till 190, 200. Okay, so what happens is, in a train test data, you can perform train test data using various methods, right? One is the cross validation, one is the and another one is using some random seed. Okay, what happens in this method? Okay, these methods take the data randomly. In the validation method, this will pick up the data in the various groups, and in the random seed, it will take the data in the form of it will take the data randomly. But these types of techniques works well in linear regression and classification problem. But in the case of time series data, we should try to divide the data in a different way. As we see in a time series data, the data is dependent, right? This both there we can say that the first variable and the second variable are dependent. The price of the day, this is the day one data, day two data, day three data. So we can say that the day two data is dependent on day one data. So we cannot take the data randomly, right? It will create a problem for us. So we should try to divide this data on the basis of date. So the first in the first time we'll take the in the first data we'll take it as a train data, and the last data we'll take it as a test data, so that as we know the data is dependent, right? So it will check, it will give a better accuracy, or it will help us in checking the model accuracy. So what I did here, defined the training size, in which I took the 65.65. Okay, I took the 65% data as training data, and rest of that as a train size. Training size, I'm defining length of df4 into 0.65, that is the 65%, and test data is the remaining data. If you want to see what is the training size, sorry. Okay, this is the training size, and if I'll print the test size, this is my test size. Okay, this is my test size. So my data is divided into the 65% for training and the rest for test size. Now what I did is, I defined the train data and test data in a way that df4 0 till this is my selecting, I am selecting my rows. Okay, so 0 to training size, that is the 65% of the data, and all my columns, this is my train data. And for the test data, I am selecting my rows of that from training size till the last of the length, and my price column, because this is my test data. Okay, it will be testing my data. Now if I want to, I've executed, if I want to see my length, okay, if I want to say my shape, train data dot shape, this is my, see, okay, this is my train data shape. And if I want to see my test data shape, test data dot shape, this is my test data shape. As you can see, my 65% is my train data, and the rest of my is a test data. So this is how you perform a train test split in for a forecasting model. In the next section, we'll be saying that how we have to pre-process the data. Okay, how we can pre-process the data. So I'll see you in the next section in the data pre-processing part. Hello, all. Welcome to our next section, that is the data pre-processing. Now in the previous sections, we have splitted our data into train data and test data. Now the next step is to create our dependent and independent variables. Now how I will be explaining how can we do that. Now suppose if I have my train data as, if I have my train data, these are for my examples. Now I have my train data as 120, 130, 140, 165 and 1 120. Okay, and I have my test data 150, 120, 146, 124, any of that sort. Now what we can do is I'll be considering different time steps. Okay, now what time step is, suppose if I want to calculate what will be the next day output, then how many days I should be dependent on, this is defined by my time step variable. Suppose I took the time step is 2, okay, 3, suppose I took the time step 3. So what happens is three new features will be created, f1, f2, f3, and finally a output feature. What happens is in the first feature the 120 will go, and 130 in the second feature, and 140 in the third feature, and the my output will be basically the next day value, right? My next day value will be my output. So this is the meaning of time step. If I'll be taking 100 time steps, then the first 100 values will be stored in my different 100 features, and the next value will be stored in my output. Now in my second iteration, what will happen, I'll shift with one value. Okay, I'll shift with one value, and first feature value will be 130, then it will be 140, then it will be 156, and eventually my output will be 120. So similarly, my different iterations will take place and my data will be collected. Okay, this will be my X train data, and this will be my Y train data. Basically this is the output, right? Because the next day output is dependent on the previous days. So this will be my X train data and this is my Y train data. Now the whole thing, this similar thing is we did for X train and Y train, and the similar thing will happen for the X test and Y test data with the test data. Now what we are doing in pre-processing is that we are converting these into independent and dependent variables. Now I have defined a simple function for that. What I did, I defined a function create dataset. In this, I'll be passing out the value, passing out the dataset value and the time step value. I've defined the time step as 1 for eventually. Now what I did, that I have defined two arrays, data x and data y. Now I am creating a for loop, right? Okay, I am creating a for loop in which I am saying it will iterate for the process for the range of length of data set minus time step minus 1. What it'll do in the a part, in the a variable, it will store all the feature value which now I have taken my time step. In the next value I have taken my time step as 100. Okay, so what I'll do, it will be appending all those 100 features in the first row, and the next output feature in my y train data, which I have done in my in the third command, data x dot append a in this A, it will be appending all those values in my 100 different features. As you can see, 0 to 99, these are my 100 features, and my 100th value will be my output value. Data y dot append data set I plus time step 0. This will be my output value. Now I will be returning that as an array. I'll be returning that as an array, data x array and data y array. Now when I be passing that, I am passing that data into my function. For x train and y train, I'll be using train data. Time step is I've defined 100. Remember, the more time step you take, the more accurate it will be, the more helpful it will be for the model. Now, if now the x test and y test is for the test data. Now if I want to see my shape, okay, if I want to see my shape, as you can see, I have 100 features, okay, 100 features. If I want to see how my x train looks like, you can see like that x train. As you can see, these each row have 100 features, right? Because I selected the time step as 100. And if I want to see my y train, I can also do that. If I want to see my y train, these are my all output variables. Okay, these are all my output. These are all hundreds in number, and this is also in 100 in numbers. So this is my x train and this is my y train. Now, if I'm printing the shape, the X train shape is 424 and the 100 columns, and this is my 424 rows. Okay. Now, what in order to feed this data, we have to reshape it. In order, we'll be reshaping it. The X train which I've defined above earlier, the same thing, and X test I will be reshaping it in order to feed this data into our LSTM model. Now, this was the whole process of our data pre-processing. Now, in the next section, we will see how we can implement our LSTM model. Hello all, welcome to our next section, which is the model building using LSTM and ARIMA. Before implementing a model in LSTM, we have to make sure to reshape our data into three dimensions. We have the already the two dimension X train and X train 0, X train 1. The third dimension we have provided here. Now we'll be implementing or importing a model where we'll be using a stacked LSTM model, which is basically the LSTM model in layers. Okay, we'll be using the sequential part, and this is the first layer, LSTM 50 return sequence. Here I am using input shape as 100 to 1. Then second layer, then this is the third layer, and this is another output layer. I'll be compiling my model. I'll be using mean squared error as the loss function and optimizer as Adam. I've already implemented it. What I did is now I'm fitting the model, and I gave my data x test and y test, and this is my validation data. This is my training data, x train, y train. Epochs is 100. I hope you are all familiar with epochs. What happens in an epochs is the complete process of forward propagation and back propagation is considered one epoch, and I have given it 100 epochs for best accuracy. Batch size is 64, verbose is 1. Now, as you see, it has finished implemented. It takes around 2 to 3 minutes to get implemented for all the 100 epochs. It depends on the time, depends on epoch, obviously. Now, as you can see, my loss function, a main aim of our model is to reduce the loss function, right? So my loss function is already decreased from the epoch of let's see uh, when now let's see from epoch of 85. See, my loss function is reduced to my exponential level. Okay, so which is a very good sign. Also my validation loss function is also reduced. Now till my 100th epoch, my loss function and validation loss function are very less. Now this is fitted my model. Now what I'll do, I'll predict my train data, I'll predict my test data. Now what I have to do, I have to inverse transform. What? Because I have to see the accuracy, right? So I'll have to inverse transform. Now what I can do, I can also check the accuracy by just implementing my mean square error method. You can also check the accuracy by that. Now we have to plot our data. Okay, so I used a simple function, I used a simple logic in that. I took my look back function. This is basically the same as my time step function. I gave it 100. I took all my nan values in my present in my data set. Then I predicted a plot in which it took the all the values in my train, all the train values in my train predict and the test values in my test predict. Then I plotted a scatter plus plotted a plot in which I remember to scale inverse transform the value. Okay, if you don't inverse transform it, it will not be able to provide you the result. I just simply plotted the graph then PL. Now as you can see, the yellow part is my train data part and the green part is my test data part. As you can see, it has performed very well. Very well. There's a simple gap because we know how we selected the data. There must be a certain gap when the train and test data. That's why there is a certain gap. But as you can see, the train test perfectly overlapped and it has correctly predicted the test data also. So this was the LSTM model. This was a, you can have a look at this code. This is a simple code in which I gave a logic to perform these lines of code. Now the next model we are using is the ARIMA model. I have explained the LSTM model and ARIMA model earlier. Okay, it is saying no module named LSTM TSA.arima. What we have to do, you have first we have to import a model. I'll show you how to import a model and use this ARIMA model in the next section. Hello, welcome to our next and final section of our project. In this section, we'll be seeing how we can implement ARIMA and how we can implement the auto machine learning technique, that is the auto Keras library. Now in order to install ARIMA, first you have to, what you have to do, you have to upgrade your patch, you have to follow these commands basically. What it will do, it will upgrade your patch size, then it will install the stats model, then it will upgrade your stats model. I have already done it, that's why it will be showing requirement already satisfied. You can install it. It will take around 1 to 2 minutes depending on your net speed and processing power. Now I'll just import my ARIMA library from statsmodel.tsa.arima model and the all other different libraries. Then I'll read my data. I'll do the pre-processing techniques which I did earlier, like renaming my petrol USD to petrol and dropping my outliers and then in resetting my index. Then I'll pass my data to my ARIMA model. In this, I just simply have to pass my values into my model and then it will forecast. I have to use forecast instead of predict in order to predict my model. Now these steps define me the number of outputs I want to predict. Now if I use here 10, then it will be predicting the next 10 values. Now if I use step here as 30, it will be predicting the next 30 values. So this is how the ARIMA model works. This was a brief introduction about ARIMA model. You can have a proper look by seeing the documentation and implementing new things from there. Now moving on to our auto machine learning library, that is the AutoKeras. AutoKeras is an AutoML system based on Keras. It is developed by Data Lab and Texas A&M University. Now to install AutoKeras, what you have to do, you have to follow these commands. First it will install the Keras tuner. Then I have already installed it, that's why it is showing requirement already satisfied. Now then you'll have to install AutoKeras. Now please make sure to make sure one thing, that you install the when you install the AutoKeras, you restart your runtime, because in Google Colab, unless and until you will not restart the runtime, it will not show you, it will not read the newest libraries which are installed. So restarting the runtime is a must. Then you can type the command pip show autokeras to see what are the versions of autokeras you have installed and other details. Now we'll implement the libraries. The autokeras is AK, TensorFlow is TF. Now we'll define our model. AK is the autokeras which I've implemented in structured data regressor. Now what this structured data regressor is? As we know, this is a time series forecasting model. So that's why the command we have to use is the structured data regressor. Now if this was a object detection or image classification problem, we would have used a different command. Now we'll just simply fit our model by using the same X train and Y train data. In the we have to we I already did the pre-processing techniques in the X train and in the LSTM model. The only difference is I am not transforming this value to a three-dimensional array, because that is the requirement of LSTM model. And if the at AutoKeras will be using the LSTM model, it will automatically be transforming it into a three-dimensional model. We don't have to do that thing. Rest all the pre-processing techniques like the train test split and converting the dependent and independent variables, we have to do that, and I have done it earlier. As you can see, my model performed 34 epochs. Now it is possible that the model which I made using the LSTM may perform better, because we used 100 epochs there, and this model is only used the 34 epochs, and you can see the loss function also not minimized that much. Now we can evaluate our model and predict our test data. Now, as you can see, we have predicted a test data, then we'll export the model. We can also see the summary that what all the models and what all the layers have been used and what is the activation function which is used. In our LSTM model, we use the Adam optimizer, but in this, ReLU function has been used. Now, we can also predict our train data. Then the last thing we have to do, we have to inverse transformer data. As we know, this has performed the LSTM model only, so we'll inverse transform the data in order to obtain the mean squared error. So we'll see what is the mean squared error from this. As you can see, we got a mean squared error of 0.07 and mean squared error of 0.008. This means that our model is predicted quite good, and this was the whole implementation of the auto keras library, and how on a small implementation of the lstm and arima models. You can check this notebook and see the different documentation on auto keras and the deep learning forecasting models, and you can implement on your own. All these notebooks and the data will be provided to you. The data has two constraints. One is the xtrain data and one is the xtest data. Both are in csv file. You can those use those data, and with the reference of this notebook you can create your own auto machine learning and deep learning models. Thank you.